Well, obviously, thank you for our attendance here. I appreciate everybody coming out today to hear about E3, who we are, and where we're going, and where we're trying to achieve opportunities here. That makes sense. To understand really who E3 is, I'd like you to hear a quote from John Muir. John Muir once said, "When one tugs at a single thing in nature, he finds it attached to the rest of the world." E3 is an opportunity. We are a house of brands, but in identifying the one thing that we need to tug at, what do we need in society? Water. So when we think of John Muir and the one thing that he says that we need to tug at, it can touch the rest of the world. What we have is an opportunity to touch the rest of the world. Now, we are applied science. We are best management practices. Our technology, we declare as being the best in the state of California. What does that mean? It's the best in the United States. What happens in California sets the standards in the production for the rest of the world to follow. What we want to derive from the practices of clean water innovation is three things: fuel, food, and health. What are we without those? You need water to touch each one of those. You need water to produce fuel. This technology here today would not be here. The dyes and the resins, the containers, if we did not have fuel to produce it. You need water to produce it. So we touch into the basis of understanding water is us. That's the one thing that we're tugging at. What we want to do with this is create longevity. Understanding that the world is selling scarcity is what the media wants you to believe. In reality, it exists for longevity purposes. Abundance over unity. Capability of understanding that we can take that energy dollar and stretch it, and extend it, and give demonstration. But you got to incentivize communities, relationships, collaborative efforts. I'm jumping right into this, but I'm not identifying the collaborative efforts that come into this. This event is being run all solar. We have water that's being pulled out of the air, atmospheric condition. Everything that we're doing is a collaborative effort. But understanding that the collaborative effort before today involved the carbon-based economy is something that we cannot ignore. What we have is a solution that enables those that are in the carbon-based economy, the stakeholder relationships, to identify with us and brand with us an opportunity to target that one thing which we all need, which they need, is water. So in understanding that we're here identifying solutions, we want California, we want the world to know that what we demonstrate here in Martinez is for a purpose and its own purpose. Because if we can get back to a foundational principle that John Muir once believed in, to create an established value for preserving the ecosystems, we can also find economics. That was the one thing that John Muir was not able to attain. How do you pay for sustaining the ecosystems? So to reward those that believe in how to sustain the ecosystem, we want to joint venture with the city of Martinez to create a platform of opportunity that scales this out, that takes it to a new level. As we know, here in the state of California, there is a lack of water and resources to water. The current solutions are fixed, permanent plants, $600 million to $1 billion in cost, but that's a one-time show. What we have is an opportunity to create job skills, skill sets, labors, educational values, moral values, and bring this technology together where a city can champion. We call it going heroic. Champion the solutions so that there will be less pollution. What we have here and what we can demonstrate, what we're going to demonstrate today, is effectively taking hydrocarbons out of the mixture of the water, Bay Area water, brackish water, where there is an abundance. Instead of going down into the groundwater aquifers, which are declining. As the population goes up, the groundwater goes down. We don't want to tap into that. So you need to go look at where there is an abundance of resources. So the technology that we can demonstrate is not a fixed base operation. It can become for cities like Las Vegas, but for here in the state of California, it makes sense to do a mobile operation to scale this technology, to give it its effectable means to make it efficient for the state. So you can move it and operate it and joint venture with other cities that are in need. Understanding that this is a collaborative effort between us and our technologies means you've got to create a platform for communities to become collaborative as well. The lack of caring, okay, let's be real, lack of caring for other cities, your neighbors, outside of your 50-mile district, man, that's the problem. So when there's a time of need, there needs to be a model of a city that can take this mobile resource and joint venture, donate, or sell the water at a discount for service of operation to these communities that need it. So understand that the future is now, and that this city used to transport one before it transported oil. Well, you could still work on the basis of a collaborative effort with oil, the carbon-based economy, because they need to reduce pollutions. Understanding that is the very key thing that you need to understand here. Because what will happen, it will model and it will shape the rest of the world by demonstrating it in one place. So I hope you understand that's the reason we're choosing Martinez. I want to be very clear about that. Connecting the verticals of income, creating reoccurring revenue is very easily attainable. Let's work at this. Let's move these operations together. It's not about money. Money will come to this. It's about proving the science, and that's what today is about. Proving that it exists, here and now. It's in existence, it's right there. Let's move it all joint venture in a collaborative effort together. Now, moving things like this to the next level means you're going to have a team. E3 team consists of the best. We have hand-selected the right people that can move and create the right policy adoptions and the solutions of these policies. There is no competition to what we have. The only competition is policy creators, those that have an agenda. Well, we don't care what those agendas are. We want the gloves to be laid down like they are, and we all want to unite and find a reason that pays people to go heroic. Branding solutions matter. It really does matter. So, in moving these technologies, you gotta have a team. Today, Michael Green is going to be talking. He's our Chief Technology Officer. Where's Michael? Inside. Michael has an aquatic engineering doctorate. He's a professional at what he does. He looks at the design structure of how you take water, the molecule of water, and you refurbish it. Everybody understands that water. Now, no one really understands that water has memory. Does anybody here understand that water has memory? Okay. I'm not trying to educate, but there needs to be an involvement of this science within the community, giving awareness that you can take technology and you can enhance the water to get abundance of fuel production, abundance of food production, and abundance of health by changing, realigning the engineering of water. That's what Michael Green does. Reinhold Ziegler, he's been demonstrating the best of the best. I like to say that he's green before there was green. He brands green. He built, things that people said that could not exist. The #1 solar project in the country of Mexico, okay, where solar is king. He built a cement factory that has to stay at 65 degrees. There's nowhere else in the world. He did that. It's the #1 solar project. Michael DeGrasso, he's our Chief Marketing Officer. A policy. He's worked in the agency world in Ohio. Which state leads the vote between Democratic and Republican? Ohio. So we've been in the fabric of creating systems within the government and also helping the collaborative joint venture between cities and stakeholder relationships in Ohio. I want you to understand that what we demonstrate here in California can become adopted. It become model. There's value for model. Now, as we move forward today, obviously we have the VIPs here and the politicians that have come, and I really appreciate everybody coming here for the right reasons. Thank you, Rob Schroeder. We will demonstrate these technologies, but I also want you to feel free to ask questions and understand that we're here and we will come back. We're not leaving. There's a reason that John Muir came here. And again, it comes back down to it that if one tugs on a single thing, he can change the rest of the world. We've identified what that one thing is, and that's water. Mark Skoda's going to get up here. Mark Skoda is a man that's been fighting a good fight. He's been over a lot of Republican, Tea Party. I'm trying to persuade him to be more in the neutral side. So, he's very gifted at what he can do. His background is UPS, developing the largest expansion of UPS to China, to Russia, Europe. There's a skill set that you got to have here, and I'm trying to identify that we are a skilled group of individuals that are here for a reason, and I hope you understand what that reason is. Thank you for attending.
All right, I get the fun stuff to do. I get to tell you about what we're going to do today and what you're going to see. You know, the water crisis of the 21st century is really intense at this point in California. We're very much aware of it. You know, when we decided to hold this press conference, we didn't believe there was going to be a drought. So the alignment between our message and what's going on around the world is important. And water is obviously the key driver, in fact, of many cultural problems that we have. The majority of potable water exists largely in the Antarctic. And so here we are today, standing before you, talking about the launch of several different technologies. And we're really excited about this because at the end of the day, this is not just science on a desk. This is actually about production-ready capability. Over the next 90 days, we'll be completing our fabrication agreements so that we can actually begin full-line production. What you're going to see today is based on a technology which is called ECOS-3 with Pulse. And we're actually going to demonstrate for you what we did yesterday, taking water out of the Martinez Bay. And actually, we're going to get to drink it if you are so inclined. Now, I already had some of that, and it's actually quite good. What we're actually going to do, though, is we're going to show you how the technology works, how we operationalize the cleaning of water, the remediation of water, and in particular, how we deal with all of the various chemicals and biologics that are embedded in water. And water, of course, is being used today for industrial agricultural processes. As we go down to California's formerly high-producing agriculture area, the wells are becoming more salty. That is, the saline is increasing. We're finding boron actually coming into the grapes and causing impact on the wine industry. If we don't begin to solve these problems now, not in 10 years, not in 5 years, not on the basis of economic and environmental studies, but on the basis of a solution which is fully mobilized, which has a low profile, no more than the trailer you see to your left, where we are able to move it where the needs occur and be able to process not only groundwater, but runoff, as well as other water that's being used. Our ECOS-3 system solves that problem. And it does so between 600 and 1,000 gallons per minute. You do the gazintas, and you can imagine the amount of water that we can process on a 24-hour day. The average desalination plant, which is a fixed base of operation, which takes between 5 to 10 years to permit, is at least $250 million. The fact of the matter is, we don't have 10 years to wait. We need to solve people's problems today. not only in terms of producing water for irrigation and potability, but also in terms of producing water and reusing water in industrial processes, in the oil and gas industry, in mine tailings, and geothermal. Eco3 will solve that problem. A lot of people ask us, why wasn't this invented before? Well, quite frankly, Mike Green's been working on this for many years with my partner, Talbot Howard. The notion is, of course, providing a mobile solution, not a fixed base of operations, to take out much of the environmental impact of the trucking operations that you see moving water back and forth today, by being able to position our units where the water reclamation is required, and then to deliver that water for its use in agriculture or drinking. And to be able to do this on a worldwide basis. We're already in negotiations on a joint venture with a group out of South Africa, MOGS, Mining or Oil and Gas Services Company, to distribute this technology throughout the continent. The fundamental problems there, even in the mines, where gold is being mined and precious metals are being mined, they're being inundated with groundwater that's mixing with the disposal water, endangering the very fabric of the mining industry. In Australia, we're launching also in the New South Wales water treatment, where there is other minor amounts of radioactive material coming into the water stream that we can actually treat. And so at the end of the day, while the objective here isn't to produce water at the cost of a municipality, it is to deal with the fundamental problems of water reclamation and water remediation. You're going to see that technology today. What you're going to see is production ready. We're not doing a science project. In addition, we are also going to be announcing our new process of E3 Irrigate. This is a system which has been designed, patent pending, which actually allows us to put an underground solution that reclaims water, not only from runoff and rainwater that occurs naturally, but from the irrigation that oftentimes is lost because it doesn't penetrate deep into the ground. The system itself is a simplified solution that reclaims that water, reprocesses, and allows potential impact of 60% increase in use of that water for subsequent irrigation. In addition, we're dealing with one last major announcement today, which is our residential commercial gray water. It's E3 RCGW. Now we'll come up with some fancy names later, I assure you. But the E3 RCGW essentially takes water, gray water from the house, and reprocesses that water using a combination of our systems here in a smaller commercial unit, and by creating a closed loop. So all the water you're using to wash dishes, clean your house, obviously take showers in, gets remediated and brought back into the house. Now, today many people look at fresh water as a disposable resource. Folks, we have all the water we're ever going to have on this planet. And as I like to say, the dinosaurs were in the water long before we started doing what we do in the water. And the problem I have is, at the end of the day, we don't look at water as a precious resource in many of our daily applications. We like a long shower. We want to make sure we flush our toilets. But the fact of the matter is, we're using fresh, potable water to do so. We have a solution. E3's RCGW solution will be commercialized over the next 90 days, and we'll begin selling that into the first of the year. The keynote here about E3 is, when I joined Talbot Howard at his beck and call to head up the operating business, we've acquired technologies around the world, we've identified key inventors that we partner with, and we've established corporations under the head of E3 Inc. to design and to operate these solutions. We're not simply selling product, we're selling an output, we're selling a service. And all of that is being incorporated not only in terms of what we do as a business, which not only includes our water remediation and reclamation business, but our biodegradable lubricants and technologies, our hydrogen-powered energy systems. We have partners such as Ecola Blue here. You have water made right from air in this cooler. Try it out today. We're working with Ecola Blue to build a distribution model that integrates, more importantly, the ability to use solar power from our friends at the Soul Man, as we like to say, which actually uses Soul Industries, which provides all the power we're using for this press conference right now, including the lighting, strictly from solar in a mobilized version. One of the things you'll hear me talk a lot about and what you're going to see today is the mobilized nature of this technology. We can no longer afford to fix base operations. We know that climate's changing over time. Demographics are changing over time. The ability to move and modify our technology in the environment and in the community is critical. And I will also tell you, everything we're doing is made in America. Now that's not to say that I'm an uber nationalist, but I believe at the end of the day, Americans designing and innovating, building with Americans, and serving Americans is a very good idea for an economy that continually is being challenged. And to do so in a way that is both environmentally friendly and economically beneficial. I like to tell people, the fact of the matter is, I want to be green. I want to change my life, but I don't want to change my lifestyle. I don't want to walk around in hemp around my body as I'm in my house or living in a geodesic dome. I like my standard architecture. And if we can begin to encourage people to make these incremental changes over time, as I like to say when I was opening up China, selling 1.3 pieces of bubble gum every day is a very good business. If we can encourage people to use these technologies at a cost basis that is not on the acquisition of a piece of equipment, but on the output of the use per barrel, per gallon, per kilowatt, we change the game, folks. And that's the vision for E3. So what you're going to see today, first of all, I encourage you to take a look at one of the units that we've used in an earlier version, Generation 1. You can go in the front of the back here. I should say don't walk across the pumps because you might tear your clothing. I don't want anybody to get hurt. But we actually have treated over 400,000 gallons of contaminated chlorine water with high particulate matter, what we call suspended solids and dissolved solids, and a major chemical spill that took place in Bakersfield, California. Inside, you're going to see our next generation solution, where we're taking the bay water, running it through the process, and then serving it out the back end to you. And we're going to challenge you, we're going to challenge some of you who are bold enough to do so, to tell me which one is the fine mineral water that is provided from Martinez, California, versus what we've just given you from the bay. So I invite you at this point to, one, come in and observe what we're doing inside. We'll be available for questions, interviews, or any answers that you might have throughout the rest of the morning. We very much appreciate your participation. We're excited. This is not a science project, this is a business. And we're very proud to be here at Martinez and Pacheco, California, to be part of this. As I told my good colleague, we're making this press announcement, and he said, "Where is that?" I guarantee you they'll know after this video. Thank you. And here's some fresh water. So if you would, in an orderly fashion, let's go inside, and we're going to ask Mike Green and Mike Del Grasso to show you the actual technology of ECOS 3. Thank you.
Good morning, everybody. Thank you for coming. I want to introduce myself and say that you have the great honor of having 3 mics here, which is a rarity in a company as small as ours. So when you say, "Hey, Mike," you're going to get a great response, I'm sure. My name is Michael Del Grasso. I am the Chief Marketing Officer for E3. And I also have the luxury of working with Mike from Research and Development and Engineering Liaison. So what I do is I tell the story of our technology in English, and then we communicate that to the rest of the world. And this is Michael Green. Michael is our Chief Technology Officer. And then in the back is the third Mike that we have, and that's Mike Lockmore. And Mike work together as part of running this research and development facility. So let me tell you what you're going to see today. Okay, and let me start this off, and then I'll turn it over to Mike for the rest of the demonstration. We went and collected over the last day water from the Bay of Martinez over here. Now, what's in that water? There's lots of ships in it, ports in it. It has a opacity to it, which is called total dissolved solids. The ships that are in the water have bilge tanks, of which they evacuate. That goes into the water. So we have hydrocarbons, diesels, so on and so forth. Okay, that's what's in those barrels, or those totes. So what we've done is we're going to show you a system We're going to show you our processing of the equivalent of what's in that tote. What's in that tote is water that has color to it and water that has oil in it. Okay? So that's representational of the coffee. Coffee has color in it, it stains your clothes, and coffee has oil on the top. And what we're going to do is sequence this, and Mike's going to give the demonstration through our bench technology. Okay, best filtering system that you can get out in the marketplace right now. We'll run the coffee through, followed by a bench model of what you're going to see with the commercial version of our technology. And again, my argument is very simple. It's easy to have a science project on the bench, as Mark said earlier. It's very difficult to process water at a commercial level that's economically feasible. So I'll turn this over to Mike, and thank you very much. I'm available for questions afterwards.
Sure.
Thank you.
So, as Mike talked about, coffee represents pretty much everything that we see around insofar as the San Francisco Bay. What you'll find is coffee is one of the hardest substances to get out of solution. Coffee, you can let it set overnight and make a cup. The next morning, the coffee is still brown. So what we're going to do is we're going to do two filtration processes first. I'm going to mix up a beaker of coffee, and we'll put it in these jugs. I'm going to process one through a very common home water filtration system, and then we'll also process through ours simultaneously. So let me get this going. Okay, so I'm going to put a teaspoon of coffee in the beaker. Okay, and we'll put the water in there. Okay, just go ahead and pour that, Mike, right into the jug.
So now if you look very closely, oils are on the surface of solution. Pigmentation is in solution.
Thank you. Okay, so through the home tabletop filtration, which is a very, very good quality water filter, commonly used everywhere, you'll be able to see the filtering effects that it has on coffee. So that's going to take a few minutes to go through. So while this is filtering through, I'm going to go over to our technology, the E3 technology, and pour this in here.
And Mike, if you would, while you're filling up and we're waiting, can you explain a little bit, just for the sake of scientific explanation, what we're using? We talk about electrocoagulation, or running electricity through water, disassociating the hydrogen and oxygen, and then flocculating water. So please explain that a little bit.
Exactly. So as Mike says, what we're doing is we're working at the molecular level to disassociate the contaminants in the coffee or in the water. It can be industrial wastewater, it can be oil frac produced water, it can be water of any nature, even the bay water that we're going to process. We're going to use the same scientific principles to do what we're doing. So right now we're applying electrical current to the water. We're using a very special mixed metal oxide anode to cathode. What we don't want to do is add contaminants back into the water that we would have to later remove. As you watch this, if you can see it, it's starting to get a foam froth on the surface. This is actually lifting the contaminants, or the coffee in this case, out of solution. The beginning water was just simply Contra Costa tap water. So what our goal here is, and what we want to achieve, is to get the water back to the condition that we started, the Contra Costa tap water. Now our technology does a number of different things. One of the things in wastewater is the contaminants, obviously, but also the bacteria, the pathogens, the things that cause sickness and disease. Our process actually disinfects the water of the pathogens so that the water is actually drinkable in most cases, depending on the starting matrix of the water, once we're finished. So we're just about there. You can see that this froth is increasing. We're splitting water. We're splitting, like Mike said, water from H2O into hydrogen and oxygen, the elements that create the molecular compound of water. There's a little bit of a chlorine smell, but that's the salinity actually in the tap water. It's not 100% salt-free. So this is just probably about ready to go. Got an extension hose here, set up.
Explain the filtration is something we're doing
So what we're running through is a series of filter media, okay? And each media is designed to remove a certain contaminant out of water. Now in the case of tap water and the coffee, it's really not going to have an effect. But let's say, for example, that you had chromium-6, very toxic metal salt. Or let's say arsenic or cyanide, radiation, you're going to be dependent upon medias to actually absorb that out of solution. And so what we have is we have alumina. Alumina is an absorbent. Alumina is one of the primary elements of aluminum. So the water will first flow through the alumina. From there it'll go into kinetic degradation flux, or what we call KDF. There's two different grades of KDF, and then we'll go into activated carbon. And the activated carbon is basically our polishing process. Activated carbon will absorb the chlorine, the fluorides, things like that out of solution.
So one thing I want to mention while Mike's turning on the pipe or on the pump is that we're removing suspended metals, suspended solids out of solution using filtration. When we run water through our electrocoagulation system, what we do is we knock down almost 100% of viruses and bacteria. They're killed. Okay, so any carcinogen pathogens out of solution as they are separated, hydrogen and oxygen, these are knocked down in the very beginning, and then the filtration then takes the rest of the metal elements out.
By comparison, what our technology is capable of doing as far as getting the coffee out of solution. You can see through the grid of what happened, and then through ours. So actually, we start out at lab scale, basically, is what we started with to develop our technology and to be able to build a scalable technology, such as Mark talked about earlier, in his talk, where we want to take this technology from the lab scale to potentially 600 to 1,000 gallons per minute. And so in doing that, we can actually walk around and see the scale version that Mark was speaking of. It's basically, we started here, we developed, we perfected, we tweaked, blah, 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 and now we'll move over here.
Yeah, and notice the differential between the filtered media, home filtering media, which is quite a good one, and ours. just on this very small scale.
This system here is designed to be expandable. It's a mobile system, a mile long in width. Basically, the feed water comes in, fills up the first tank. It's exposed to the same process that we did over on the last scale, the electrolysis process. The water then transitions through the collection chamber in the center into the second tank. And as that's going on, we have a fully automated computer system, or what we call PLC, that operates and controls the levels of the tanks, and also the collection of the contaminants that we throw off the surface. So,
Which mic?
Okay. So, basically, again, like I said, the water comes in first in the first module, transitions up and over into the second module. You'll actually see that the water is getting clearer here. Again, it follows the same process. And I think we're ready to pull a sample. Excuse me,
Yeah, give it go for a bit. So what Mike was saying, you can see the coloration differential between this tank and this tank. And it's continuing this sort of block created on the surface of it with water. This rate rates the flock off into collections. So if that flocculant happened to be oil, hydrocarbons, or anything that was recoverable from solution, we can literally recycle it into the collection tanks. Okay? So in the oil industry, the fracking industry, we're able to take hydrocarbons out of solution and recover it. Okay? For secondary processing, we're turning it into any type of fuel, biofuel.
Again, it's a fully automated machine. This machine can be in New Mexico. We can operate it right here from our office.
There's an app for that, right, Mike?
Yeah, the solar man plugged up our Wi-Fi.
Yeah.
Great technology.
Let's go into this a little bit more detail while we're kind of going over something. But we have two power supplies. Each power supply is unique to each set of cathodes and anodes. Okay, when I talk about cathode and anode, I talk about plus minus, just like you see on a battery. So when frequencies are put through and water is subjected to those frequencies, that's DC current. This goes into an input device, wiring on the back. It creates an electrical stimulation of the water. That electrical stimulation disassociates the water molecules. The plus of it is the emitter of ions, the minus of it, which is the leader, the collector. And then what happens is the contaminant rises to the surface, and from the surface then we reconstitute the water by reassociating with hydrogen and oxygen. And that's how we can release the contaminants to the surface and then reconstitute water back.
Okay, so this is the finished product coming through here.
The water.
No salt, no taste.
So we go from
Bay Area. I'm still here.
We'll talk about when it's
Mark, over on that other bench.
and show you how we device. But really, this is probably the main water. This is water. So we're putting right off the roof, right off the coast for the day. And then we suck it up, and then we're bringing it out. And we're just running it through a reverse osmosis. Solid material rises to the surface, and typically when you scrape it off the surface, we really have to scrub it out. Yeah, so
Now,
these are the
you
collective.
gotta try this, folks. This is bay water. Believe it or not, that's right out of Martinez Bay. And by the way, just so you know, we've had it tested, so you're going to be perfectly fine, but give it a shot. And what we'll do is, what I want you to do, if you're so inclined, is take a glass of the Alhambra mineral water, which we have right behind you, and then take a sip of this water and see what you think tastes better. And see if you notice a difference.
You find that when you're